Just so that we're clear, let's summarize what we did here to solve this problem. What's our takeaways? I just want you to think for 15 seconds. Tell your neighbor, what do you want to remember every time we're doing synthetic division? All right, let's bring it back in 3. What's off in 2? Have all eyes on 1. Thank your partner.
Thank you.
Yeah. Go ahead and jot down those takeaways that you want to remember. Capture them at the bottom of your notes page. We subtracted 1 from the degree here. So this is 3 minus 1 means that the first coefficient here is going to be 2. Every time that you're writing the quotient from the synthetic division. All right, let's share out. What do you want to remember? What's your takeaway? Let's go Clarabelle, Brito, and then Kendra in that order. Try Clarabelle. I'm sorry, Clarabelle. Thank you.
You can only use this method when the given factor is linear.
Only use this when it's linear.
I said also put a placeholder or you get the wrong answer.
Always put a placeholder, you get the wrong answer.
I said that the quotient, when you're writing a quotient, the remainder must be written over the divisor.
When you're writing the quotient, the remainder must be written over the divisor. Let's add one. Another takeaway, what about the way you write the quotient? What about that is important? The way we write the quotient. Casey?
That if there is a value that exponent is higher than the first value, you need a placeholder. I need help
Okay.
rephrasing my sentence.
Yep. Vanessa? Make sure it's written in standard form. That's key. Angel?
Do the exponents have to be in standard order?
Yeah, they have to be in descending order. Fagan?
Are you talking about the structure of writing?
Yes, the structure. Thank you.
So when you get the answer, you do the quotient plus the remainder over the divisor.
Over the divisor. Last comment.
Okay, can I add on to this thing?
Yep.
Alright, I would say when the remainder is not 0, you do the quotient plus the the quotient plus the remainder over the divisor.
Yeah, so we're saying a lot of good stuff. Snaps for you all. It's time for practice. Flip over to the next page. You have 5 minutes to silently and independently answer problems 1 and 2. As you work, I'm going to be coming around to give you feedback. All pencils are moving in 3, 2, and 1. I'm coming around to check for the correct root and coefficients. Good, you got your root, you got your coefficients. Good, you got your root, you got your coefficients. I'm coming around to check your quotient. Good. Keep going, make sure you have your quotient there. It's good, Fagan. Pick a process of your choice. What's going on? Oh, good. Make sure you have your quotient. Good. 1 minute, 30 seconds. If you haven't made your way to the bottom to start working on the second problem, you should. Ooh, check that quotient. Keep going, Kenyatta. Ooh, much better. Thanks for that strategy. We will check that quotient. I'm coming around to check for any revisions that you've made based on my feedback. Yep, that's it. Good job. Okay, let's look at this. So I want to look at one of your peers' work. Let's look at Angel's work. And Angel is about 60% of the way there. And we need her to get to 100. And I saw this on a few of our papers, about 25% of our papers. What advice would you give Angel? Turn talk, 30 seconds, go. So let's bring it back in 3, voices off in 2, and 1. What advice would you give Angel? Let's put our eyes on Rylan.
For this, I put my degrees on top of each step. So for 2, I put 3 at the top, so I know that is to the third, and then at that for negative 11, I put X to the second degree, and then for 15, I put X, and then at that just going and then going.
So this process that Rylan is describing, what is he doing here? By just placing those degrees above the coefficients. Why is it necessary to do that? Clarabelle?
Because at the end, when you're trying to find the quotient, you're going to need to add the exponent afterwards. So it's easier to put it at the top just to remember.
Yeah, just to remember, I agree. What other advice would you give Angel? Kelly?
Pay more attention when you're combining the numbers, because negative 11 and 6 would give you negative 5.
So we have negative 5 here. And this one subtle change of a sign is going to do what to our final answer? Javon?
Turn the divisor into a factor.
Turn the divisor into a factor, because our remainder is going to be different, 0, right? What's our takeaway here, though? Because I saw this on about 25% of our papers. What do we want to remember every single time we're doing these type of problems? What's our takeaway from this problem? Kendra?
I would say that carrying around the signs, that paying attention to the signs when we put it, because that changed the answer drastically.
Always carry our signs when using synthetic division. Always carry our signs when using synthetic division. Snaps for Angel. Thank you for letting us learn from you. Christiana, can I see this? So now let's look at Christiana's quotient. Snaps, if you got this. What did Christiana have to do to get this quotient? I'm coming around to check the quotient. Killing it. Yeah, keep going. Make sure you have the remainder in that quotient. What's going on here?
Yeah, 60.
Yeah, so make sure that your work is aligned vertically so that it's clear to the reader. That's good. Good. Much better, thank you. We'll check that remainder. That's good. Good. Thank you for circling it. Just starting. So check this. Let me see this. That's good. Pencil down, track me in 3, 2, and 1. Wait, no one. So as I walked around on a few of our papers, I'm noticing that we're getting an incorrect remainder. But we have check mechanisms in place to check this. There's multiple strategies that we can use. So snaps first for Fagan for using long division. You didn't have to use long division. You don't have to use synthetic. There's even another approach that I saw in Kenyetta's paper. But what's a way that we can quickly check if this remainder is correct? So say you have some extra time. What's the way you can check? Kenyetta?
Plug in what the 0 would be and see if it equals 0.
And what theorem is she using there? Isaiah?
Using the remainder.
And so if we plugged in 3, substituted 3 in for our function, we get what? And so that conclusion would tell us that something in our work is incorrect, because when we use the remainder theorem, we know that the remainder should be 248. Okay? Let's just go back to practice.